So how do you effectively manage JavaScript memory and garbage collection? JavaScript is an interpreted language. Originally was browser resident only, meaning a browser would have the JavaScript interpreted language embedded in it. That has been in play for many years, but a number of years ago, it's been detached from the browser and moved to a standalone environment, namely the Node engine that allows JavaScript to execute it on servers in a headless manner. Like many modern languages, memory allocation and deallocation is an automatic process. We no longer have to manually program in and allocate the memory that the program is going to use and then afterwards deallocate it, like some earlier languages were. Advanced garbage collection algorithms can determine and free up unused memory, so that JavaScript employs that. However, it's not a foolproof mechanism, and developers can inadvertently write code that prevents these advanced garbage collectors from doing their job. That can result in memory leaks that inhibit performance and can cause the application to crash. What are the things that can prohibit garbage collecting algorithms from doing their job? Circular memory references are one of them, where variables in the program or objects in a program reference another variable, and then they reference each other in a circular manner. That can keep the garbage collector from freeing up that memory because it thinks it's always in use. Global variables. Global variables are convenient at times, but if they're defined outside of the scope of a function or a code block, then the garbage collector will not free that memory up. It'll be globally accessible. In some cases, that's necessary. However, you should use prudence when defining these global variables, because they will not be garbage collected. The memory that they access will not be freed up. Direct references to DOM elements. The DOM is the data structure that JavaScript browsers reference to work with HTML that's appearing to the user. And these references are commonly accessed and used for a UI feature or function. Direct references to that DOM are not garbage collected, and that can lead to a memory leak. Code blocks or closures that reference variables defined outside of the code block can also inhibit garbage collection. Memory management in JavaScript is something that Java developers don't have to always be cognizant of. The previous issues I talked about need to be kind of in the back of your mind, but for the most part, it's pretty automatic. But some best practices that you can apply to help with this is use global variables wisely. There are cases when they are necessary, but don't go overboard with them. Remove event listeners. There's a lot of event listening capabilities in JavaScript, especially with the DOM, where one event can occur and something can happen. Those things need to be dereferenced manually when we know where they are. Use let instead of var when you're defining your variables. The variables defined using the var keyword are function scoped. So the garbage collector has more work to do in determining if it needs to be freed up. Let is scoped to the code block level, so it's a little more efficient way of defining your variables, and it also helps the garbage collector determine when that variable is no longer referenced. Null out or dereference variables that hold on to DOM elements or closures. So if you have variables that are holding on to DOM elements or closures, you need to explicitly dereference those, null them out, or undefine them. Lastly, use memory profiling tools. Chrome has them built in that will allow you to scan your application when it's being used, and it will give you memory graphs and give you a pretty good insight into how memory is being garbage collected, how it's being allocated, deallocated, and it'll sniff out memory leaks. As always, if you have any questions on this or would need some assistance, feel free to send a note to asktheteam@keyholesoftware.com.